9.9. We're gonna be talking one more time. 9.8. I made a video of it Thursday and posted Thursday morning. Because that was something that we had to get done last week. We just didn't make it to it. So it's like a quick, I think it's like 15 minutes or so to go back and just watch that, come back with questions. This is the compound inequalities. So it's like solving regular inequalities, but you have like numbers on both sides of the equation. So instead of doing like one, that you do one side to the other, you do what you do in the middle to both sides. So it's like doing two problems at the exact same time, pretty much. So if you're going to add or subtract in the middle, you add or subtract on the outside. If you multiply or divide in the middle, you multiply or divide on the inside. And then I talked about in there as well on how to graph those cases. If the letter is between the two numbers, you just graph in between. And then just pay attention to, is it a parentheses or bracket, depending if there's a line underneath the inequality or not. And that's pretty much this. And I think there was a couple of word problems at the end, which was all about I think there was an average one, like what was the minimum grade they would have to make to maintain a grade. So it's like at least an 80 or something like that. So, but if you got questions on it, by all means, after you look at, just ask. I don't mind helping. All right. So on this one, this will be 9.9, and then we'll do 9, 10, and then jump into chapter 10 and go as far as we can. But this will be absolute value equations. We talked a little bit about absolute value one day. I think I said, like, what's the absolute value of 2? So you'll see these little bars here. Those are absolute value bars. So what's the absolute value of 2? Anyone know? 2. What's the absolute value of -3? 3. Remember, absolute value is just distance from 0. So we're going to take that idea and set up absolute equations, basically. So here we go. So we're going to start off with this. You're going to see something like this. The absolute value of x equals 8. So the idea here is, what two numbers can I plug in here that will be 8 numbers from 0? Two numbers that are 8 numbers from 0. Perfect. And so the idea behind this is you take the equation you see, and that's your first equation. So I see x equals 8. I'm going to drop the absolute value bars. The second equation, you're just going to change the sign of what it's equal to. So now it's going to be x equals -8. In this case, that's all it is. So these are your answers. So 8 and -8, if I plugged into the absolute value, would give me 8. Does that make sense? They might want you to write it like a set. So -8, comma 8. Yes, that's a comma right here. Oh, these are, I think they're called cursive brackets. If I was to slow down on this, it's supposed to look like this. I'm really bad at it. So I just make some squiggly lines. But when you see something fancy like this, it's just a set notation, meaning it's like you use these things when you're listing things. So I'm listing -8, 8 as my answer. But if I wanted to list like 1, 2, 3, 4, then I could do that with the set brackets around it. Let's look at a little bit harder question now. Actually, this will be still in part A, or part 1. This will be part A. This will be part B. So now I have 5x minus 2 equals 8. So with the same concept that I had here, the interior part of this can either be 8 or -8. So now we have to then determine, well, what x value will give me 8 or -8. So the way we do this, I'm going to say 5x minus 2 equals 8. So I drop the absolute value bars. That's my first equation. My second equation will then be 5x minus 2 equals -8. Because again, this equation inside can either equal 8 or -8, and that would have been 8 numbers from 0. The key now is to now take our skills from chapter 9.1 through 9.8 and now solve these. So what would I do to solve this equation? Eight plus 2. What would I do next? I did. I heard. Yeah. So I was just writing it out. 10 divided by 5 is 2. All right. Now I solve this one. How do I solve this one? -8 plus 2. Positive or negative? Very good. You're good. And then what? Simplify if you can, but -6/5 would be the answer. Or if you like decimals, you can write -1.2. I mean, it doesn't really matter. I personally like the fractions. But then that's it. So then your answer here would be -6/5, comma 2. All right. The key mistake students will make, they'll solve this, get 2, and then automatically assume the answer is -2. Right? That is not the case. Is that me? Oh, you're good. I was like, I thought it was me earlier. Then it was like even louder. I was like, man, it's aggressive. So we're good with that? All right. We got 2x plus 5 absolute value equals -6. So let's talk about this. Can an absolute value equal a negative number? It cannot. So therefore, this right here would be a no solution. So anytime you see absolute value bars equal a negative, don't do any work. You can do work and you'll get answers, but they'll be wrong because absolute value cannot equal a negative. Now, the x value can be negative when you solve it, but the absolute value itself cannot be negative. So this will be your answer. Are we okay with that? So watch out for that because you'll get into the groove of things and then you'll solve it and you'll get an answer and be like, man, I swore I did that right. And you probably did mathematically, but you can't equal a negative number. All right. So let's look at another one. 7 absolute value, 4x plus 1 absolute value, plus 5. Oh, that's a plus, sorry. Plus 5. I don't know why I'm bolding everything as I write. Equals 54. I was just trying to make sure that these are absolute values and not ones. Yeah. Gotcha. All right. So before you can set up your two equations, you have to isolate the absolute value. So I first have to get rid of this plus 5 and this times 7. Then I can split up my two equations. So how do I get rid of this plus 5? So I'm going to subtract 5. $54 minus 5. Now what? Divide. This 7's being multiplied, so I want to divide it. It does 7 times. So now that the absolute value is isolated, now we can split up our two equations. Go ahead. $49 divided by 7 is 7. No, you're good. Yep. So now I'm going to split these up into my two equations because now I can, because the absolute value is now isolated to itself. So this becomes 4x plus 1 equals 7. That's the first equation. And then 4x plus 1 minus 7, that would be the second equation. So, yeah. So in this case, 7 or negative 7 could go in. So what's the first step? Okay. Seven minus 1 would be? Now what? If you simplified 6 over 4, you get 3 over 2. Or if you like decimals, you can say 1.5 as well. Right? Either one of those answers would be correct. How do I solve the second side? Oh, go ahead. So I took the equation 4x plus 1 equals 7. I subtracted the 1. That's 7 minus 1, which was 6. And then to get rid of the 4, I divide it by 4. I know that looks like a 1, but that's a 4. And it simplifies to 3 halves or 1.5, whatever you prefer. So now what would I do with this equation? Subtract 1. And then divide 4. So I get negative 2. So then x would equal negative 2, 3 halves, or 1.5, or whatever it is that you like. The squigglies get worse and worse on the right side. I just don't know how to do it backwards one. Typically, you're going to have like a box on your thing, and it's already going to have like squigglies around it. You just got to type in the numbers. Typically, the directions usually say least to greatest. If they don't, then technically you can write in any order. But a lot of times they'll say least to greatest. So I don't want you to get it wrong because you did all the work, but then you didn't put this in the correct order. It's like negative 2 is smaller than 3 halves. Roof. Oh, this here, I'm just splitting it into two separate equations. So I'm showing that this equation turned into this and this, because this can either equal 7 or negative 7, and it would be 7 numbers from 0. So that's what the little roof thing is, to show that it's split into two different equations I have to solve. And believe it or not, I only have one more question for this section. Yeah, I got one more. Yeah. We're good so far, though? Yeah. Again, I'm available. Yeah. I will say a lot of times, most of my students, they'll do like, I don't know, like a Snapchat or a Snap group or group chat. That's it. And so they can text each other and stuff like. I'm totally good with that. Best way we learn is from each other, because I might have an idea, you might have a better idea, and then I'm like, that's a great idea. Let's go with that idea. But it all depends. We don't all see it the same way. All right. So on this next question here, we'll have the absolute value of 4x minus 5 equals absolute value 3x minus 16. All right. Same type of process. I'm going to set up my two equations. I'm going to leave the first equation as is, as if there wasn't any absolute values at all. Those becomes 4x minus 5 equals 3x minus 16. That's the first equation, as if there was never absolute values. The second equation, I'm going to leave the first one as is. But then all of this has to change signs. So you can go ahead and do that, or you can write it out like this. The reason I have to do this is it kind of goes back to this concept. It's equal to 7 and negative 7. The only difference is we don't have one term that's changing signs. We'll have multiple terms that will change signs. So you can either change them and write it out that way, or you can apply a negative and then do it, however you need to see it. If it's a double absolute value. All right, so if we look at the left side, how would I solve the left side? Using what we know from that last week. I got to put it together, but they're on opposite side of the equal sign. So which one am I going to move? Smallest. And what is 4x minus 3x? 1x. Now what are you going to do? Now, earlier you said to move the 5. Not a wrong step. You can technically do that, but then you still have to put the x's to one side. So there's not like one smooth way of doing it. I find it easier to put the x's on one side, then get rid of the constant division, but you're not wrong by doing that. As long as whatever you decide to do, you do it on both sides. Negative 16 plus 5. Negative 11. You did. You said. Gotta be confident. But this is like, yeah, this is you owe someone $16. You pay them back 5. You still owe them 11. Or you take the difference of the two, 16 minus 5 gives you the 11. So that's your first answer. I'm going to take that negative now and I'm going to distribute. It would. So I have a negative 3x and a positive 16. So like I said, you can either do it right away or you can do it as you're on the next step. So now I'll add 3x. So 4x plus 3x. Now what? Add 5. There's a 16 there. Yeah. Oh, I gotcha. You're good. And then, yes, 16 plus 5 is 21. So x is 3. So our answers here are negative 11 and 3. And that pretty much is all your homework on 9.9. Oh, like the so one like this one here. I gotcha. All right, I got one. Like I said, I would have probably recommended this course to be a 16-week course because if you're in this course, math is probably not your strong suit. So doing it in an 8-week span is I would say pretty it's hard. You're welcome. So this is just a random example. Just kind of looking at your book to find another one like D. So we got 5 absolute value of 3x plus 17 minus 4 equals 51. So like what we saw in D, what do I have to do first? And how do I do that? Okay. I think you're all about to say it. 51 plus 4 is. Oh, go ahead. Ask it. Oh, this one here. Oh, because this one's technically not a like term. Because technically this is attached to something that has an X when you multiply it like that. Because the biggest misconception is a lot of students will see this, something like this right here, and they're going to want to add this first, but you can't because the 5 is technically attached to the X, so you can't add those. Perfect. So now what would I do? Mm-hmm. Very good. Positive or negative? I mean, -6. You would still owe $6. Basically, you solve it the same way, but does not mean you'll get the same answer. Perfect. You owe someone 11, borrow another 17. Now you're -28 in the hole. I don't think 3 goes into 28. Yeah. I think if it would have been 4, I think then it would have been 7. Yeah. So in this case, I can just leave it like that. I wouldn't. That's a 3, by the way. I wouldn't go any further. Yeah, 9 times 3. Yeah, yeah. Yeah. So it'd be like 9.3 repeating or 9 and 1/3 or something like that. So this is the same thing, give or take, -9.3 repeating. Mm-hmm. Yeah, you can't reduce that any further. All right, so we good with absolute value equations. They're just like our regular equations, but then we end up with 2 answers. One that's equal to the positive version of what we have it set equal to, and one that's equal to the negative version. And then we use exactly what we did last week to solve. The conclusion of chapter 10 is absolute value inequalities, solved the exact same way. right? The only difference with inequalities is what? Do y'all remember? If you multiply or divide by a negative number, you must flip the inequality symbol. Other than that, it's the same. All right, so let's jump into 9.10.